I draw a picked graph of this, what's going on in this question, just to get a bit more of a feel for it. So I don't know what this curve looks like. I mean, we could think about it, but it's not going to be that essential. What I'm going to draw is a sort of cubic to, it's not necessarily going to look like this. In fact, it's not going to look like this, but it's going to set the scene. So I've got a cubic here, and that's this one in blue. And then we're told that we've got a line y equals 8x plus 3. So let me draw it like over here. And then we're interested in the coordinates of the points on the blue curve where the tangent, the curve, is parallel to this line. And that means it'll have the same gradient. So maybe I draw these tangents, and there would be one here where it just touches, and there would be one right here. So I've got the m is equal to 8, and what we're interested therefore in then is the points on the curve where we also have the instantaneous gradient in this case as m is equal to 8. And that leads us into what we need to do in this question, and that is to find dy by dx. First of all, I'm going to write it as y is equal to a third x cubed plus 9x to the minus 1, because now I can differentiate it. Dy by dx is going to be x squared, like times by 3, that's going to cancel, lower the power, and then I'm going to get minus 9, because I'm timesing by minus 1, x to the minus 2. And it's going to equal 8 at the points where the tangent is parallel just trying to justify it. Ultimately, we have to solve this equation. So x squared minus 9 over x squared is equal to 8. And we have a hidden quadratic here. I'm going to times through by x squared, first of all. X to the 4 minus 9 is going to be 8x squared. So x to the 4 minus 8x squared minus 9 is equal to 0. Now it's your choice at this point. You can, if you want, do a substitution. I don't know, what should we, let u equal x squared. Or you can just factorize directly in terms of x squared. Because that's what it's a quadratic in x squared, essentially. I'm going to go for this one. So I'm just factorizing it like a quadratic in the normal sort of way. Two numbers that multiply to give minus 9, add to give minus 8. It's going to be minus 9 and plus 1. If you did the substitution for info, then you'd get that u squared is equal to x to the 4. Therefore, u squared minus 8u minus 9 equals 0. And then, yeah, you just factorize it in the same way. U plus 1, u minus 9 equals 0. But in both cases, well, here we're going to get u is equal to minus 1 or 9, but then we have to remember that it's actually x squared. Here you just get it directly. X squared equals minus 1 or 9. Going to reject this one because we can't square a real number to give a negative. So we just have the x squared is equal to 9. And therefore x1 is going to be minus 3. x2 is going to be 3. Or of course you could just say x is equal to plus or minus 3. I'm just separating it because we're asked for the points, coordinates. I will probably bring them together at the end. Okay, we're nearly there, but remember we're asked for the coordinates, so I now need to use find y. Now we do not want to use the y here, this green line. This green line just gave us information about the gradient. It's not actually going to give us the correct y coordinate. We want to find the y coordinate on the curve. So I need to substitute my x equals minus 3 and my x equals 3 into here. So y1 is going to be a third times minus 3 cubed plus 9 over minus 3. Minus 3 cubed is minus 27, times a third is going to be minus 9. Here, I'm going to minus 3, I'm going to get minus 12. Let's see if I can fit this one in here. y2 is then going to be a third times 3 cubed plus 9 over 3. So this time it's going to be 9 plus 3 is going to be 12. And the coordinates are therefore minus 3 minus 12 and 312.